Hello, everyone. Welcome back to the second lecture of the chapter Practical Geometry. And in this chapter or in this lecture as well, we are going to learn few more cases, few more good cases or the important cases from the point of view of your examination. And before we move to that, it's very important to revisit the concept of, or it's very important to revisit the weightage of the chapter as far as your school examination is concerned and your Olympiad examination is concerned. So let us quickly go through that. So if you talk about school examination, in school examination, you can expect questions carrying around 6 marks. That means you can expect around two questions, 2 to 3 questions at maximum from this particular chapter, and the questions that you get from this particular chapter are quite easy. Like all the cases that we are covering or we have covered already, you will see the questions more or less from those topics only. So you just have to practice a good number of questions based on those topics to be sure of getting these 6 marks. All right, without practice it's not possible, right? Like mathematics means practice actually. And if I talk about Olympiad weightage, then in Olympiad, 1 to 2 question can be expected. Like from the point of view of Olympiad, this chapter is not that important. So around 1 to 2 question you can expect from this particular chapter. So it's more important from the point of view of your school examination rather than your competitive examination. All right, so let's move ahead and see which topics are we going to cover in today's session. So here are the 3 topics listed down which we are going to cover in today's session. The first topic is constructing a quadrilateral when 2 adjacent sides and 3 angles are given. So we are going to learn how a quadrilateral can be constructed when you are provided 2 adjacent side. I hope you all know the meaning of adjacent side. Adjacent side means side by side actually. Okay. Then apart from that, if you are provided any 3 angles of that particular quadrilateral, how that particular quadrilateral can be constructed, that's what we are going to learn. If you talk about topic number 2, in topic number 2 we are going to learn quadrilateral, or we are going to learn how we can draw a quadrilateral when 3 sides and 2 included angles are given. What is the meaning of included angle? The meaning of included angle is, let's say I draw one quadrilateral here. Okay, this is any quadrilateral. Let's say this is A, this is B, C and D. So let us assume we are provided this side, you can call it x unit or x centimeter. You are provided this side, that's y centimeter. You are provided this side, that's z centimeter. Then the meaning of included angle means you will be provided the value of this angle. I'm assuming this angle here to be alpha, and you will be provided this angle as well, and I'm assuming this particular angle here as beta. So when you are provided any 3 sides and the 2 included angle, how you can draw or how you can construct a quadrilateral, that's what our second topic will be. And if we talk about the third topic, our third topic will be how a quadrilateral can be constructed when other spatial properties are known. What's the meaning of other spatial properties? Means how you can construct, let's say, square, if you are provided some of the values or related to that particular square, or how a rhombus can be constructed if the sufficient values or the sufficient measurements are provided to you in the problem, how we can construct all of them. That's what we are going to learn in today's session. Understood? So I think we should start with our topic number 1 for today. So this is your topic number 1. Topic number 1, we are going to learn how a quadrilateral can be constructed when 2 adjacent sides and 3 angles are given. So here I have taken one problem to explain this thing to you. We have to construct a quadrilateral PLAN. Okay, plan. Okay, I'm going to call it plan. And we are provided PL. Okay, you are provided LA. So PL and LA, these 2 sides are the adjacent sides of this quadrilateral plan here. Apart from this, what do we have? You are provided angle P, which is 90 degree. You are provided angle A, that's 110 degree. You are provided angle N, that's 85 degree. So you are provided 2 sides, PL and LA. Apart from 2 sides, you are provided 3 angles, and the angles are angle P, angle A and angle N respectively. Then how this particular quadrilateral can be constructed. That's what we are going to learn today. All right. So let's see what can be done. We know that when we are talking about quadrilateral, guys, quadrilateral means how many interior angles does a quadrilateral have. If you are talking about quadrilateral, a quadrilateral always have four interior angle, and we also know that the sum of all the four interior angles of any quadrilateral, I repeat, any quadrilateral, is always equal to 360-degree, right? So because we are provided three angles here, so I think by using the angle sum property for quadrilateral, the fourth angle can easily be calculated. And maybe when we will learn how the construction can be done, you will see like what's the benefit of calculating that fourth angle, or how that fourth angle is going to benefit us. Let's see. Okay, so we know that the sum of angles of a quadrilateral is 360-degree. We all know that, right? So angle P plus L plus A plus N is going to be 360-degree. I know the value of angle P, which is 90-degree. Understood? I know the value of A, which is 110-degree. I know the value of N, which is 85-degree. I'm not aware of the value of L, so I can calculate the value of L. And if you solve it, what will you get? You will get angle L is equals to 75-degree. So now when we got angle L is equal to 75-degree, what can we say? We can say that now we know all the four angles of this quadrilateral, and apart from all the four angles of this quadrilateral, we also know the two adjacent sides. Let's see how we can now draw it. So what is our first step? I will also show you the figure, guys, don't worry. What's our step number one? In the step number one, we are going to draw side PL, which is equals to 4 centimeter as per the information which is provided to us in the problem. And you have to draw an angle 75-degree at L. Understood? So let's see here. So you know PL, check out. PL is provided to be 4 centimeters. So this is your PL, let's say. Okay, PL, and this is 4 centimeter. All right, so we are provided it. You have to draw this PL using a scale. Now, if we go back, what's the value of angle L? We got angle L, we got equals to 75-degree. So you have to draw 75-degree using compass. Okay, and how can we draw 75-degree? To draw 75-degree, we can bisect angle 60 and 90-degree. All right, so we have to draw 75-degree at this L here. So what are we going to do? 1 second, let me choose another color to show you that. Check out. So I have to draw 75-degree at L. So you will assume L to be the center, okay? And you will draw a semicircle of any radius here. Understood? Now, assuming this to be the center, this point to be the center, you have to mark an arc of the same radius, like the radius which we assumed of this semicircle. So this is your first arc. Okay, this will denote 60-degree. Okay, this will be a 120-degree. And if you bisect these two angles by taking more than half of it, what will you get? You will get 90-degree. So this is going to be your 90-degree angle here. All right. So this is 90-degree. This is 60-degree. So now I have to bisect this. So if you want to bisect it, what you need to do? If you want to bisect it, what you need to do is you need to take more than half of it and bisect it. Okay. If you take more than half of it and bisect it, you will get somewhat like this. Like your figure will appear somewhat like this. And this angle is going to be 75-degree. All right, this will be 75-degree. So what are the first two steps? In the very first step, you have to draw PL, which is equals to 4 centimeter using a scale. In the second step, you have to draw angle L using compass. Whenever you are provided any angle that's a multiple of 15-degree, you always have to use compass. Like I would suggest to not use any other thing. Then what is given? Then what's the next step? In the next step, as vertex A is 6.5 centimeter away from L, or in other words, you are provided the value of LA. So what you have to do, you have to cut a line segment LA of 6.5 centimeter from this ray. Let me show you. Okay. So what you have to do here, you have to assume L to be the center, Assuming L to be the center, you have to mark an arc of length 6.5 centimeter on this line, on this ray. Okay. So this is where the arc is going to cut it. For example, we are going to call this point as A, and the length of this line segment is going to be 6.5 centimeter. So we have got our LA as well. I repeat, what we did here, we have to draw LA which is equals to 6.5 centimeter. And if you want to draw LA that's equals to 6.5 centimeter, all you have to do is you have to assume L to be the center. Assuming L to be the center, you have to mark an arc of length 6.5 centimeter on it, and the point where the arc is going to cut this line segment, we are going to call that point as A. Clear? Now what other information do we have? We have, or we know the value of 110 as well. Okay, we know the value of 110, like angle A, we also know angle A as well, right? So again, draw an angle of 110 at point A. That's what you have to do. Okay. So at point A, you have to draw angle 110 degree. Understood? At point A, you have to draw angle which is equals to 110 degree, guys. Clear? So if you want to draw 110 degree, how you are going to construct it? That's what my question from all of you is. What should be done to draw 110? What should we do? You can use D also, like yeah, protector also, yeah. So you have to draw angle A which is equals to 110 degree. Like I am assuming this is angle A and this value is going to be 110 degree here. Understood? Now what else needs to be done? What other information do we have? Check out. We have drawn angle A. So after drawing angle A, what you have to draw is you have to draw an angle equals to 90 degree at point P. This ray will meet the previously drawn ray from A at one point. Okay. So what you have to do is you have to, because we are provided the value of angle P, if you observe here, you are already provided the value of angle P. So we are going to draw angle P here, which is equals to 90 degree. So angle P. So again, assume P to be the center, make a semicircle of any radius, then assume this point to be the center, mark first arc, which will be equals to 60 degree, mark second arc, that will be equals to 120 degree, bisect both of them by taking more than half of it, and this angle is going to be your this angle is going to be your 90 degree. So this is a rough figure, guys. Okay, this is going to be your 90 degree. One second, let me redraw it. Understood? This is going to be a 90 degree here. Now these two rays that we have, one of the ray which is drawn from point P and the other ray that is drawn from point A, they both are going to cut each other at one point, and you are going to give a name to that point, and the name of that point is going to be N. Okay, so we finally got our quadrilateral, which is PLAN. Okay, so angle P is 90 degree, L is 75, A is 110, and what was the value of N? That is 85 degrees. So this angle that you have here, it will automatically be 85 degree. Okay, if your construction is done properly, this angle is automatically going to be of 85 degree. I hope this is very much clear to all of you. Please go through it once again and ask me if you have any query in it. Is it done? Okay. So here we have one more problem that we have to try from our side to draw. Okay. You have to construct a quadrilateral. Let me choose another color. You have to construct a quadrilateral ABCD. You are provided AB and BC equals to 5 centimeter and 3 centimeter respectively. So basically AB is equal to 5 centimeter and BC is equals to 3 centimeter. Also three angles are: angle A is 120 degree, angle B is 110 degree, angle C is 90 degree. So because we are talking about this quadrilateral ABCD here, so in this quadrilateral ABCD, what will be the sum of all the three angles? So in quadrilateral ABCD, you will have A plus B plus C plus D, that's equals to 360 degree as per angle sum property. A is 120 degree, B is 110 degree, C is 90 degree, D we are not aware of, we are interested in finding out its value, so that's equals to 360. You have 120 plus 90. 120 plus 90 is 210, so that is 210 degree, and 210 degree plus 110 degree, that is going to be 320 degree. So that means your value of angle D is going to be 40 degree. Understood? That's 40 degree. So you can check it. 120 plus 110 is that is 230, plus 40 is 270, plus 90 is 360. Understood? Now let us understand how this quadrilateral can be drawn. We know the value of angle A, we know the value of angle B. Let's see. I'm going to first draw A. Okay, I'm going to first draw AB, or yeah, AB I'm going to draw. So let's say this is my AB. Clear? AB, that is equals to 5 centimeter. AB is equals to what? That's equals to 5 centimeter. Understood? So this has to be your very first step. Now, what is the value of angle B? Angle B is provided to us, that is equal to 110 degree. Okay, 110 degree. So you have to draw angle equals to 110 degree using productor. So this is, let's say, 110 degree. Okay, this angle is 110 degree. Understood? So we have drawn 110 degree. Now this is A, this is B, and here we are going to have the vertex C. So what's the length of BC? BC is given to us equals to 3 centimeters. So what we are going to do is, we are going to assume this B point to be the center, and we are going to measure an arc of radius 3 centimeter, and we are going to mark that arc on this ray. Let's say that cuts here. Okay. So this will cut it at some point, and you are going to call that point as C, and the length of this BC will be equals to 3 centimeter. Understood? That's equals to 3 centimeter. Clear? So we have drawn AB, we have drawn angle B, we have drawn BC. Now I need to draw angle A and angle C. If I can draw that properly, I'm done with this problem. What's your value of angle A? Angle A is provided to us, that's equal to 120 degree. We all know how we can easily draw 120 degree using compass. So again, make a semicircle of any radius. Understood? Assuming this point to be the center, mark first arc, which will be equal to 60 degree. Mark second arc, that will be equals to 120 degree, and then join that second point of intersection of second arc with A. So this is going to be a 120 degree. Clear? This will be a 120 degree. Understood? What's the value of angle C? Angle C is provided to you, that's equal to 90 degree, guys. So here you have to draw 90 degree angle. So again, you can use compass for that. So first arc, second arc, okay, you bisect it at a point and then join it. All right. So these two rays that we have drawn, first by drawing angle A, which is equal to 120 degree, and drawing angle C, that angle C is equal to 90 degree. These two rays are going to cut each other at one point, and you are going to call that particular point as D. So this is your point D, and this point D will automatically give you angle 40 degree, like when you will draw using instruments that we have in construction box. Okay, then you will get the value of angle D 40 degree exactly. If your construction or if all the steps that we discussed are done properly, I'm sure you will get the correct answer. So that's how you have to draw it. I hope you understood this first thing, where you are provided any two adjacent sides, And apart from any two adjacent sides, you are also provided any three angles, then how the construction needs to be done. Done. All right. So this is for your reference, guys. Like if they ask you to write the steps in your examination, this is how exactly you have to write the steps in your examination. Okay, so please go through it once. So like you can go through it. This is like what happens actually. Some people start with some other initial step. Some like if you ask any second person, he will take the first step as some other value or some other step. But eventually what happens is we all come down to the, or we all come across this final result. That's important rather than like from where we started and all. So you can go through this solution, and please go through these steps. I would highly recommend to go through this, because they can ask you to write the steps in your examination. In case of any issue, feel free to get in touch with the expert. So we are going to discuss now second case, guys. So what's the second case? Second case is you have to construct a quadrilateral when you are provided any three sides and two included angle. I told you the meaning of included angle. Included angle means the angles that are lying between the three sides that we are considering here, or you can say the angles which are formed by the three sides under consideration here. Understood? Again, one example here. You have to construct a quadrilateral which is true with the following measurement. TR is given 3.5, RU is given 3 centimeter, UA is given 4 centimeter. So any three sides are given to us. Apart from that, two included angle R, that's equals to 75 degree. You can use compass, that's it's a multiple of 15 degree. And angle U, that's equals to 120 degree. Again, a compass can be used, that's again a multiple of 15 degree. So what are the steps that you have to follow? This case is very easy case, so don't worry. Your first step is you have to draw side RU, that's equals to 3 centimeter. So I will also keep on showing how you have to draw it, although a proper figure is mentioned here. So this is, let's say, RU. And what is the length of RU you have? The length of RU is given to us, that's equal to 3 centimeter. Understood? Now, what is the value of angle R? Angle R is given 75 degree, and angle U is given 120 degree. Now it's up to you guys, which angle do you want to draw first? It does not matter actually. So as because here in the steps it is mentioned that first we should draw angle U, that's equals to 120 degree. So I'm going to start with that only. So at point U we have to draw 120 degree, and we all know how 120 degree can be drawn using compass. You have to assume U to be the center. Let me use another color to show that. You have to assume U to be the center. You have to make a semicircle of any radius of your choice. Then you have to assume this point to be the center. Mark first arc of the same radius. Now assuming this to be the center, you have to mark second arc of the same radius. The second arc, the point where that second arc is going to cut, that circumference of the semicircle is going to give you 120 degree. So this angle that we have here, that's going to be 120 degree. Understood? So this angle will automatically be 120 degree. Is that clear? Now, as vertex A is 4 centimeter away from U, cut a line segment UE of 4 centimeter from this ray. What are they trying to say? Let me show you. They are saying we know the value of UE. What's the value of UE? UE is equals to 4 centimeter, and we can easily draw it. You have to assume U to be the center, and you should mark an arc whose length is equal to 4 centimeter on this. So let's say this is the arc, and the arc is going to cut it at this point. And because this is going to give us the length of UE, you are going to give a name to this point, and the name of this point will be E. Okay. So that is UE, and UA is equals to what? That's equal to 4 centimeter. Clear? Now, exactly same steps are going to be repeated with this vertex R. What's the value of angle R? Angle R is given to be 75 degree, which is an acute angle, and we all can easily draw it. So let's see how we can do it. So at R, we have to draw 75 degree, and 75 degree can be drawn by bisecting 60 degree and 90 degree, right? So again, a semicircle of any radius. Now this point should be assumed as center. First arc, which is going to give you 60 degree. Second arc, which is going to give you 120 degree. And when you will bisect 60 and 120 degree, what will you get? You will be getting 90 degree. So this is 90 degree. Okay, let's say. Right. Now, when you will bisect 60 degree and 90 degree, let's say it cuts here, like let's say this is what, this is where the arcs are going to cut. Then this angle that you are going to get here, this angle is going to give you 75 degree. Understood? So this angle that you have, this would be equals to 75 degree. So we got angle R as well. And that's exactly what they have written in this point, guys. Now, what is the length of RT? The length of RT we are already provided, that's equals to 3.5 centimeter. So what you need to do, you need to assume R to be the center, and assuming R to be the center, you have to mark an arc of length equals to 3.5 centimeter on it. So assuming R to be the center, let's say we are marking an arc of length 3.5 centimeter on it, and this is where it cuts. So this is going to be T, and the length of this will be equals to 3.5 centimeter. Now what you have to do is, all you have to do now is join T and E using a scale, and you will automatically get your required quadrilateral, which is true. TRUE. Is that very clear? I think that's what you have to do, guys. I told you it's not difficult. It's super easy if paid attention to. Then I think we should have one more problem on this, isn't it? Let's see one more. So what we have here, we have to construct a quadrilateral ABCD. Adjacent sides AB, BC, AD. These are 5, 3, and 4 centimeter. Angle A and angle B equals to 120 and 110 degree. Because you are provided the value of A and B, you should first draw AB. So what's the length of AB? AB is equals to 5 centimeters. So we are going to draw AB first. Let's say this is our AB. A, B, and AB is equal to what? That's equal to 5 centimeter. Understood? Now, what is the value of angle A and angle B? Angle A is provided to us, that is equals to 120 degree. So you can draw angle A. So to draw angle A, what we have to do, assuming A to be the center, mark or draw a semicircle of any radius. Then assume this to be the center. The first arc will give you 60 degree. The second arc will give you 120 degree. Yep, this one. Okay. This is 120 degree. Now, what is the value of ABCD? What's the value of AD? AD is provided to us, that's equals to 4 centimeters. So assuming A to be the center, you have to mark an arc whose length should be equals to 4 centimeter on this ray. So let's say this is where the arc is going to cut. And the point where the arc is cutting this ray, you are going to call it as D. So the value of AD that you have, that's equal to 4 centimeter. Understood? That's equals to 4 centimeter. We got. Now we have to repeat exactly same steps with this B as well. So the value of angle B is 110 degree. So we have to draw 110 degree using protractor. You can do it. So 110 degree will appear to be somewhat like this. Okay, 1 second. Let's say this is your 110 degree. Understood? So this value is 110 degree. Clear? Now what is the value of BC? BC is provided to us, that is equal to 3 centimeter. So assuming B to be the center, you have to mark an arc whose length is equals to 3 centimeter here. And the point where the arc is going to cut this particular ray, we are going to call that point as C. So this is C. And after that, all you have to do is you have to join C and D. C and D. So we got our figure. So we finally got our required quadrilateral, which they were asking us in the problem. And what's the name of that quadrilateral? The name of that quadrilateral is A, B, C, D. This is A, that's B, that's C, that's D. Okay. Go through it and ask me if you have any query. Is it done? Okay. So again, here you have solution for your reference, guys, which you can refer. And again, I would suggest to not miss the steps of construction in any situation. 1, 2, 3, 4, 5, 6 steps have been mentioned, and the figure is given to you alongside. Do not forget to go through each and every step thoroughly, because they might ask you in the examination. Like that's what we have to do here. I hope you got this topic. Okay. We have one more case, guys. You have to construct a square. Like now we are going to learn about this spatial spatial quadrilateral, we can say. All right. So we have first case. What does this first case says? One second. You have to construct a square ABCD, each of whose diagonal is equal to 5.2 centimeter. So here, like, see, whenever you have to construct the spatial type of quadrilaterals, it's very, very important to be aware of the properties of all the spatial type of quadrilateral, like parallelogram, like square, rectangle, like rhombus, kite, everything. Okay, every spatial type of quadrilateral that we have, the properties of those spatial type of quadrilaterals should be on your fingertip, because if you know the properties of those special type of quadrilateral, it becomes super easy for you to draw. You will observe here how we know that the diagonals of a square bisect each other at right angle. We know that, right? So we are going to use that thing here. Okay. And the diagonals are equal also. So first they have drawn any one diagonal AC, which is equal to 5 centimeter. So let's say this is AC. All right. This is A, that is C, and the length of this AC is equal to 5.2 centimeter. Now, because they bisect each other at right angle, that's what the property says. So bisecting at right angle means that bisector will be a perpendicular bisector of AC, and we all know how a perpendicular bisector of AC can be drawn. So you assume, one second, let me choose another color to show you that. You assume A to be the center. You assume A to be the center and measure more than half of this length AC. I repeat, you assume A to be the center and measure more than half of this length AC. Mark one arc here. Okay. Second arc here. Clear? Then assume C to be the center. Keep the arc length unchanged. Okay. Mark one arc here and the second arc here. What you will observe is these two arcs that we have drawn, they are going to like these two arcs, one below, one above AC and one below AC, they are going to intersect each other. And when you will join their point of intersection, you will easily get the perpendicular bisector. Understood? So this bisector that we have here, this is going to be the perpendicular bisector. All right, this is the perpendicular bisector. And this point, because this perpendicular bisector is going to give us this other diagonal that we have of this quadrilateral or this square. So we are going to call that point of intersection as O here. Okay. Now, because we know that the diagonals of a quadrilateral bisect each other. So from O, set of OB, that is equals to half of 5.2, which is the length of diagonal, and half of 5.2 is 2.6. Because the length of the diagonal, the other or the second diagonal which I have shown in red, the length of that particular diagonal above AC from this point O will be equals to half of this entire length, because they bisect each other, right? And half of this entire length of diagonal means that length should be equals to 2.6 centimeter. Then all you have to do is you have to assume O to be the center. Assuming O to be the center, mark an arc of length 2.6 here. Then again assuming O to be the center, mark second arc of length 2.6 below AC. Okay, those two arcs are going to cut this perpendicular bisector at some point, and you can give name to that point. Let's say this point is D and that point is B. Okay, now all you have to do is you have to join AD. Clear? You have to join BC, you have to join CD, all right, and you have to join AB. And if this is done properly, although my square is looking something else because I am drawing by hand, okay, if this is done properly, you will easily get your required square. 1 second. Okay, so this is going to be a square. That's it. Understood? All the angles will automatically be 90-degree here. So you don't need to worry about that. If these steps are followed properly, you will get the square automatically. All right. So go through it and ask me in case of any query, guys. All right, done. So now we have one more situation here where when we have to construct a rhombus with side 4.2 centimeter and one of its angle equals to 6.5 centimeter. All right. We all know that what rhombus looks like. Rhombus looks like this, right? I'm just drawing a rough figure to give you an idea of what all we have to do. So let's say this is the required rhombus, that is PQRS. Okay. I'm assuming this angle to be 65-degree. So if this angle is 65-degree, this angle will be 180 minus 65 degrees. So that is going to be what? That is going to be 115-degree, correct? That is going to be 115-degree. Okay. All right. And these length are going to be 4.2 centimeter. This one will also be 4.2 centimeter. That one will also be 4.2 centimeter. Understood? All right. So let's see how we can draw it. So here I'm assuming the name of my quadrilateral or the rhombus to be PQRS. Okay. So let rhombus be PQRS. Okay. Then I'm assuming angle P is equals to 65-degree. Understood? Clear? Therefore, what will be the value of angle Q? Therefore, angle P plus angle Q, that will be equals to 180-degree. Okay. Co-interior angles, right? So what's the value of angle Q? Angle Q will be equals to 180-degree minus angle P. It is important for us to calculate because without this, it will be difficult to draw. So you will have angle Q is equals to 180 minus 65. So that means the value of angle Q is equal to 115-degree. Okay. So we know any two angles. We also know all the four sides, I would say here. So it's very easy to draw. Let's see how. So here first I'm going to draw PQ because I know the value of angle P and I know the value of angle Q. So let's say this is your PQ, guys. All right. And because in rhombus, the length of all the sides of the rhombus is always same. So what will be the length of PQ? PQ is going to be 4.2 centimeter as given in the problem. Understood? What is the value of angle P you have? Angle P is equals to 65 degree. So 65 degree you can draw using protractor or D. All right. So let's say this is your 65 degree which you have drawn using protractor. Clear? So this is 65 degree. Understood? Now what else do we have? We know that the length of all the sides of rhombus is always same. So assuming P to be the center, you have to mark an arc of length equals to 4.2 on this ray. Okay, let's say this is where it cuts and you are going to call it S. So this PS will automatically be equals to 4.2 centimeter. Same steps needs to be repeated with point Q as well. So, but what's the value of angle Q? Angle Q is 115. So 115 can again be drawn using T or protector. So let's say this is your 115, guys. Clear? So 115. Because the length of all the four sides is same, so assuming Q to be the center, you have to mark an arc of the same length, which is equals to 4.2 centimeter here. So this value is going to be 4.2 centimeter automatically. Now you are going to call it R. Now what needs to be done to get your required quadrilateral, that is PQRS? All you need to do is you need to join R and S. When you join R and S, you will automatically get your rhombus and all the properties that are there in rhombus will be satisfied here. Okay. So PQ will be equals to QR, that will be equals to RS, that will be equals to PS. Angle P will be equals to 65 degree as per the information which is provided to us in the problem. And the other angle, the adjacent angle, is going to be 115 degree here. So that's exactly what you need to do here, guys, to draw any rhombus with side 4.2 centimeter and one of its angle equals to 65 degree. I hope you all got it. Right, done. Okay. So this is for your reference, guys. You can go through this solution and especially do not forget to go through the steps of construction. They first drew BC, which is 4.2 centimeter. You can check here. Then CBX is equal to 115 as the sum of co-interior or adjacent angle is equal to 120 degree. So they have drawn 115 here. BCY is equals to BCY is equals to 65. That's what they have drawn here. Then they marked arc of length equals to 4.2 centimeter, assuming B and C to be the center. So this is 4.2 centimeter here. That value is 4.2 centimeter as well. And the point where they are going to cut, they have called those points as A and D respectively. All you need to do is you need to join A and D by using a scale, and you will automatically get your required rhombus, and the rhombus here is ABCD. I hope that's very clear to all of you. Okay, all right. So here we have three questions that you have to try as a homework, guys. Okay, and these three questions are strictly based on the three topics that we covered in today's session. In first topic, what we learn? We learn when we are provided any two adjacent sides and any three angle of a quadrilateral, how that quadrilateral can be constructed. So the first problem is based on that. The second problem, which you can see on your screen, that is when you are provided any three sides and two included angle. Any three sides and two included angles are provided, then how that construction of quadrilateral can be done, it's based on that. And the third case is the spatial type of a quadrilateral. So we discussed how we draw a square, we discussed how we draw rhombus, and here you have to draw parallelogram as a homework. All right. So I hope you understood all the topics that we covered in today's session. If still you have any doubt or any query in anything, feel free to get in touch with your expert and he or she will definitely help you out with that. All right. So that is it from this session. Thank you so much for attending. I'll see you in the next one. Goodbye.